Okay, subelement G3 is radio wave propagation, and this is what makes high-frequency operation really interesting. It's radio wave propagation, and it's quite a science, it's quite an art, and you'll never feel like you have it all figured out. No matter how much you know about it, you'll never feel like you have it all figured out. So we start out with a real basic question here. What is the sunspot number? And it's just a count of the, where are we, based on counting sunspots and sunspot groups. Okay, there we go. Measure of solar activity based on counting sunspots and sunspot groups. Here's the image of the sun. Here's a group of sunspots. Here is the Earth superimposed on the picture here for scale, so you can see what size that sunspot is. It's not just a fly speck, even though it looks like it on the face of the sun. The Earth could actually go in there and get lost. What effect does a sudden ionospheric disturbance have on the daytime ionospheric propagation of high-frequency radio waves? It disrupts radio signals on lower frequencies more than it does on higher frequencies. A sudden ionospheric disturbance is an abnormally high ionization density in the D region of the ionosphere caused by a solar flare. We'll look at these regions as we go on through the slides here. The sudden ionic disturbance results in a sudden increase in radio wave absorption. These lower layers, the D region, absorb radio waves. That is most severe in the medium frequency and lower high frequency ranges, and as a result often interrupts or interferes with telecommunication systems. If I remember right, I got this out of Google, or not out of Google, out of Wikipedia, for the definition of a sudden ionospheric disturbance. So there are all kinds of sources for this stuff. Sometimes you can go to Wikipedia, sometimes you can just Google a term like sudden ionospheric disturbance and find some information. Approximately how long does it take the increased ultraviolet and X-ray radiation from solar flares to affect radio wave propagation on Earth? Now this is electromagnetic radiation, the same as light, and it travels at the speed of light, and it takes it only 8 minutes to reach the Earth from the sun. Okay? Ultraviolet and X-ray are electromagnetic radiation that travels at the speed of light. Which of the following amateur HF frequencies are least reliable for long-distance communications during periods of low solar activity? During low solar activity, the higher frequencies are least reliable. Right now, we're in a period of relatively high solar activity, and the higher bands are often very active, especially during the daytime, and they're really fun. You can operate worldwide with fairly low power and need not even too much for an antenna when the solar activity is high. What is the solar flux index? It's a measure of the solar radiation at 10.7 centimeter wavelength. This is the actual answer on the test. What they're referring to here is the length of the radio wavelength. What is a geomagnetic storm? It's a temporary disturbance in the Earth's magnetosphere. The Earth has a magnetic field around it that's called a magnetosphere, and if you have a disturbance, solar wind, particles coming from the sun can disturb that magnetosphere. And a geomagnetic storm is a temporary disturbance in the Earth's magnetosphere. At what point in the solar cycle does the 20-meter band usually support worldwide propagation during daylight hours? The 20-meter band is the most reliable band we have for long-range worldwide communications, and it's pretty good at any point in the solar cycle during the daytime. Which of the following effects can a geomagnetic storm have on radio wave propagation? Degraded high latitude HF propagation. Now, by high latitude, we are talking about farther away from the equator. Okay, and the reason is because this is where the magnetic pole is. So the more intense magnetic field near the magnetic pole will cause a geomagnetic storm to have a greater influence at the high latitudes nearer to the poles. What effect do high sunspot numbers have on radio communications? Long-distance communication in the upper HF and lower VHF region is enhanced when we have high sunspot numbers. What causes HF propagation conditions to vary periodically in a 28-day cycle? This is an interesting one, and I did not know this until when I started teaching general. I didn't know this until I looked into it a bit. But the sun rotates on its axis with a period of 28 days. So the sunspots that you're looking at today will rotate around on the sun, and if they're still in existence 28 days from now, they'll come back into view as that face of the sun comes back to us. So propagation conditions can vary on a 28-day cycle. Approximately how long is a typical sunspot cycle? The test answer is 11 years. Okay, and you can see them here charted out. Here was a peak. Here's another peak in around approximately 70 or 71. Here's another peak in about 1980. And they varied from 9 years to 13 years, but we typically talk about them being 11 years. Here is the present. The number here is the cycle number. Cycle 20, cycle 21, cycle 22, cycle 23, and so on. We're presently in cycle 24, and they've projected it here, and it's not really as active as it looks in this this particular graphic. What does the K index indicate? The K index is the short-term stability of the Earth's magnetic field. And this also affects radio communication, the A and the K index, short-term stability in the Earth's magnetic field. A index is the long-term stability in the Earth's geomagnetic field. How are radio communications usually affected by the charged particles that reach the Earth from solar coronal holes? The charged particles generally cause disruption of high-frequency communications. The solar flare, the coronal mass ejection of particles causes a disruption of high-frequency communications. How long does it take charged particles from coronal mass ejections to affect radio wave propagation on Earth? Okay, now we said 8 minutes for the electromagnetic radiation, right? But these things are particles. They can't travel at the speed of light. So for these, depending on how what the speed of ejection was, we're talking between 20 and 40 hours before the particles from a coronal mass ejection reach the Earth. What's a possible benefit to radio communications resulting from periods of high geomagnetic activity? High geomagnetic activity create auroras, and auroras can be used to reflect VHF signals. In fact, that's one of the fun things that the guys in the northern latitudes do. When the aurora is strong, they'll actually reflect their VHF signals off of that and make contacts using the aurora as a reflector for their signals.